Okay, so once again, thanks very much for joining us for this short 15-minute webinar. My name is Kevin Ward, one of the support and training geoscientists here at Petrus in Glasgow. And I'm going to take you through a short webinar on grid editing, showing you the ability in Petrus to add and edit faults within an existing grid. Now, just a couple of housekeeping things before we get started. Please note this webinar is being recorded, and that's so we can add the recording to our website when we're finished. And also note that you are all muted at the moment, but at the end of the webinar, I'll unmute everyone if there are any questions. Okay, so this is the agenda for the webinar then. We're going to start with a very short introduction. We'll then go into a live demo using the software to show you how we actually go about doing this editing. And then there's some extra information where you can learn more and where you can contact us. Okay, so what is this webinar about then? Well, in general, it's about the new grid editing capabilities within Petrus. Now, for those of you that are long-time users of Petrus, you'll know that back in version 17.6, which is a couple years old now, we released a tool called the Spatial Editor. Now, this is an easy-to-use graphical editing tool that you can use within mapping, and it's a very powerful tool that allows you to edit things like contours and faults as well as GIS data. The limitation with that tool was always that when you made changes to contours or to faults, you had to go out of mapping, you had to go into surface modeling, and you had to use this data as input to regenerate a grid. Now, based on client feedback, we have significantly improved this workflow, and in version 17.8, we released a new grid editing tool or editing capabilities within the Spatial Editor. So the idea is now that when you edit your contours or your faults, you can simply press buttons within that tool to regenerate the surface, making the whole process of editing significantly faster. Now, thinking more specifically about this webinar, what we're going to do today is look at how we can add and edit faults within a grid. Now, I have a grid displayed on the screen here, just a simple grid with a colour-filled display. And you can notice there are some areas in here where you might think we can infer the presence of faults. The first thing I would always say when you are about to do this is to change the display to try to highlight the faults as well as you can. And one of the main tools to do this is the sunshaded grid option that we have in Petrus. So if I flick to an example of that, using the same grid and using a sunshaded grid, it's much easier to infer the presence of faults based on slope change and based on the shadow effect from a light source. So when we have displayed the sunshaded grid and we've identified the faults we want to use, there are then some options within the Spatial Editor to create the faults and edit them. So you can see up in the top right of this screen, we have a fault drawn in one of these dark shadow zones, and there are then some icons to refine that display and also set up some information about the fault, so we can change the up thrown and down thrown side of the fault. We can back interpolate from the grid to get Z values on the fault. So there are numerous options within the editor. The key thing is that when we have made those changes, there are two icons in here to regrid the grid with the faults incorporated and to contour up to those faults. And so we'll go through those in the live demonstration. So I'll move now to the demo. So I'll jump out of PowerPoint. And I have my Petrus map window open here. And this is the data that I'm going to use to do the fault editing within the grid. Now the first thing you'll notice is that I'm using sparse data, sparse 2D data, and that's because typically this sort of operation is done using sparse data or poor quality seismic data. Obviously, if you have very high resolution 3D seismic data, you're probably going to interpret most or all of the faults within that interpretation itself. When you're using more sparse data in exploration or when you're using poor quality data, you'll often find that when you display the grid, there might be areas where you haven't interpreted a fault on the actual seismic, but the shape and style of the geometry of the contours suggests that there might be a sharp change in slope consistent with a faulted horizon. So that's why I'm using some sparse data. Now before the webinar started, I gridded up this data and I'll just display the results just now. This is it here. Now I've displayed the seismic ribbon map with a slightly different colour gradient so you can actually see it. But effectively this grid in the background here has a low area in the middle and some high points down in some high structures down on the south here. This also has some faults interpreted, and these faults have come from the seismic data itself. Now what you might notice in this grid here is that there is an area to the north here where the contours become closer together and show a sharp change in slope, but no fault has actually been interpreted in this area. Now particularly this sort of contour geometry where you have this sort of Z shape is quite typical of a faulted horizon. But as I mentioned earlier, when you are trying to infer the presence of faults, it's critical to use some of the more advanced display options that Petrus's has, and the one that I recommended earlier is to go to Display Grid and then Sun Shaded. Now I'm using the exact same grid here, the Vola two-way time grid, and you can set up various parameters to display this the sun shaded grid. Now if you hover over these boxes here, it will tell you a little bit more about how to set this up. So in this case I'm using a light source that comes directly above this area, and if I click apply you can see that the actual image is significantly different to the colour fill display, but it picks up sharp changes in slope very nicely. So in this case you can see this sharp change in slope here along this area we identified earlier. And in fact, if I change the sun angle a little bit more, so if I reduce the angle of the light source, you'll see that it's now picked that up even better. So using the sun shaded grid and playing about with those parameters makes it much easier to identify these faults. When you have identified the fault, we can then go on to the next stage, which is to use the editor to edit or to create new faults. Now to do that, I'll move this fault into this grid into this group. All you have to do is right click on any of your grids and select Edit. When you do that, it launches the Spatial Editor, and you'll notice that I have access to a whole range of grid editing tools. Now before we go and actually start to edit, there's a few things you might want to change about the editor to set this up specifically for editing them faults in this type of workflow. So the first thing I'm going to do is I'm going to change from the grid nodes mode to the contours mode. The reason for that is that once I have edited this fault in this area, I'm going to want to remove these contours so that the regridding process has some degrees of freedom to recontour back up to that fault. So I've changed the contours mode. The next thing I want to do is select the gridding tab, and I want to toggle on automatically regenerate contours. The reason for that is that in this particular workflow, when I've edited the grid, it's crucial that my contours are updated along with the new grid. I don't want those to be out of sync. So I'll toggle that option on, and the other thing I want to do is I want to change the grid definition here. So I right click on this layer here and I select grid definition. Now the two things I want to change about this grid, the first is I want to toggle off the compute grid within faults, because these existing faults don't have any grids created within them. So I want to toggle that off so that I'll get white space within the fault that's only going to contour up to the edge of the fault. Second thing I want to do is to reduce the cell size. And I'm going to reduce it to 10 by 10. The reason for this is that quite often when you're creating a grid using sparse 2D seismic data, although the cell size might be fine for gridding your seismic data, it's not an appropriate cell size for gridding very narrow faults. And so quite often you'll find that the software will have a difficult time trying to contour around the faults when your cell size is too large, and you'll often find you might even get some white space as well. So within this editor, very easy to actually change the cell size of the grid. Now when I click OK, I'm going to get a very important question here. It's going to ask me whether I would like to regrid or whether I would like to resample by when I'm changing this cell size. And the answer here is that I want to resample the grid. I don't want to regrid the data. And the reason for that is that if I did regrid this data, it would regrid using this contour spacing that you see here. And in actual fact, there's a lot of detail in between these contours that would therefore be lost. So what I want to do is I want to click on No to say that all I want to do is resample the grid, and therefore it will just add in the extra grid nodes that I need to increase the resolution here. Final thing I want to do before I get started on the editing is I don't want to view the colour fill display, I want to view the sun shaded display. So to do that, I just toggle off the colour fill within the editor, and up here in the display list, I just toggle back on the sun shaded display. and I can now zoom in and start my editing. So to edit, I'm going to click on this fault here, and I'm going to extend this. Now there are numerous icons down here to use, and I'm not going to go through all of them, but I will say that if you hover the mouse over those icons, they will tell you what they do. Now in addition to changing the geometry of the fault, there's also some icons to change the properties of the fault. So I can assign fault flags, I can swap faults up and down, I can clip contours within faults, or I can grid within faults. And I can also back interpolate to add Z values onto the fault. In this case, I'm just going to select the eraser tool, I'm going to erase a little bit of that fault, and using the pencil icon, I'm going to come back in and just extend this fault down. And I'll just do this fairly quickly for the purposes of demonstration. Now you can either single click like this, you can right click to remove points that you don't like, and you can click and drag if you prefer to work in that way. It's up to yourself how you like to work. And I'll just close that back off. Now once I've done that, I'll toggle off the sun shaded grid, and I'm going to toggle off these contours, and I'm going to go back into the fault, and I'm just going to apply some smoothing to this just to make it look a bit nicer. And obviously you can spend as long as you want to get this fault looking perfect, but that will do me for this demo. So now that I've generated the fault, we now get to the real advantage, I guess, of the new grid editing features, and that is the ability to recreate the grid within the editor itself. Now before I do this, you'll notice that I still have the existing contours for this fault, and also if I regrid using these existing contours, it's not going to change the geometry very much. So I need to get rid of these. Now there's two ways to do this. I can either highlight the fault, and I can click on this icon down here to clip those contours within the fault. However, in this case, I want to leave a little bit of room between the fault and outside the fault. And so to do that, I'm going to use the eraser. I'm just going to create a little buffer around the edge of that fault polygon there. Something like this. And I'm now ready to recreate the grid. Now you have two options within the editor. You can do a full regridding, or you can do a localized regridding. Now most software packages will only offer you the full regridding option when you make any changes. The problem with doing a full regrid here is that when you do create a grid from these contours in any software package, you will lose a lot of detail between the contours, as I was mentioning earlier. Now you don't want to do that. You don't want these changes to affect the high quality data you have in other parts of the grid. So what you want to do is you want to use the advanced feature in here called localized regridding. You click on this and you'll get this pink polygon around the area that you've edited. Then you can expand the area if you need to, like so. However, in this case, I'm going to stick with the original buffer of 1. And when I click OK, what will happen now is the grid will be regridded in the edited area, but anything outside will simply be resampled and no changes will be made. Now when I've made those changes, I can now just going to jump to the grid nodes mode, and I'll just jump back to the contours mode, just a little trick to get this tool to refresh. And when I've done that, you can see that I now have my updated contours coming into this fault nicely. And what I'll do is you can now save the grid, or you can save as if you want to change the name. I'm simply going to save this grid, close it down, and then we close the editor down, and then we can view the results back in mapping. So if I toggle on the grid itself, you can see that we now have this fault coming through here. We've extended it. We've got nice contours coming up to it. And if I click on some of these contours, that's 1610 and that's 1650. So about 40 meters of throw, and that's reasonably consistent with, on the unedited part of the fault, 1510, 1550. So we've extended the fault quite nicely there. One final thing to show is that if I display the sun-shaded grid, you'll see that we no longer have that very dark area up here because we've extended this fault into the correct area. Okay, so I'll jump back to the PowerPoint and just finish off very quickly. First thing to say is that this webinar is actually the fourth in a four-part series on the new grid editor. We've done a webinar on the introductions and more about the localized regridding. We did a webinar on a workflow which digitized an image of some contours and then generated a grid from those published journal contours. The third workflow was on modifying grid nodes themselves, and this one's all on adding and editing faults within a grid. Now all of these videos will be available on our website, petrus.com.au/support/videos. And of course, if you want to ask us any questions about these workflows or ask us any questions, or if you want to set up a one-on-one session where we can discuss these in more detail with your specific workflows, please do contact us at support. We're always happy to offer those sort of one-on-one sessions. So thank you very much for listening. What I'll do just now then is I'll pause the recording, and I will also